John Pike, the landslide guy.
Hey guys, it's John Pike, the landslide guy here. We're studying landslides and seeing how vegetation and soil composition affect levels of damage by runoff. Now we're going to pass the shovel to my partner Kayla for some background information.
Mudslides can be caused by rapid erosion that comes from large rainfall or snow melting really fast. Some risks are if the land's been altered by humans or if there's like wildfires. And the soil composition, the steepness of the slope, the thickness, and the looseness of the soil are big factors.
This is worthy of investigation because every year in the United States, landslides cause approximately $1 billion in damage and 25 to 50 deaths.
So after doing the dirt mudslides, the first one that did not have any vegetation had a 30% decrease in slope after the mudslide, while the one with vegetation had a 37.5% decrease in slope after the mudslide. However, the runoff of the one without vegetation was 25% more than the one with vegetation, which shows that the vegetation did decrease the runoff, which is the real danger in mudslides because it causes damage to buildings, cars, picks up big things, and by having vegetation you can decrease the loss of life.
After 2 trials of using soil to emulate thicker composition, we are now moving to sand to emulate very thin composition of soil, of sediment.
Alright, so one problem we ran into in our experiment is that we had initially planned to cut the edge of the box so that the runoff would go straight into a separate container that we could weigh for to determine how much runoff there was. But since the box was too thick for us to cut, we devised a new method of transferring the runoff into a new container and then weighing that to determine how much runoff there was. The looser soil or the sand was easily able to compact and absorb the water at first. However, the drawback to this is once it reaches its breaking point of how much water it can absorb, all the soil begins to slide at once.
This is in contrast to the thicker settlement because water was unable to be collected and thus pooled at the bottom. There was constant movement of sediment down the slope, but it was at a much less rate.
The implications of the loose soil trials are that in areas of less rainfall, loose soil provides better defense against mudslides since it can absorb the water and compact. In areas of heavy rainfall, though, loose soil can be dangerous since once it gets fully saturated, it all begins to slide, which can lead to a lot of damage.
By performing these experiments with and without vegetation, we have determined that in areas of thick soil composition, vegetation proves an effective way of decreasing mudslides because the roots are able to hold together the sediment and decrease chance for it to slide off. In areas of loose soil composition, the roots of the vegetation is unable to take hold and thus proves to have no effect on the potential for mudslides. The implications of this are that in areas of thicker soil composition and are susceptible to mudslides, vegetation can be used to effectively decrease probability of mudslides and damage.
Alright, so after performing this experiment, some new questions that arose and that we could expand on with our landslide experiment are how buildings affect landslides and also how landslides affect buildings. So to test this, we could implement model buildings into our landslide that we pour the water on and see what effect it had on those.